good morning or good evening, wherever else you may be. I'm Emmanuel Thanasoulis from Aston University. I'm very pleased to introduce Ali, colleague of mine. Ali is going to make a very brief introduction to DEA, but the main focus of the talk is going to be on features of data envelopment analysis which have been implemented with the PIM DEA software. So I'll also want to just say that there is a facility for you to put questions, which after Ali has had a time to make a presentation of certain features, we'll stop briefly and answer some of the questions before proceeding on. Okay, so over to you, Ali.
Thank you, Emmanuel. This webinar, as Emmanuel explained, is about introduction to DEA, and the main focus would be on the PIM DEA software. So how to run DEA with the PIM DEA software. Before we start, there are a couple of things that I need to inform you that we recommend you position the speakers in the top right corner when the orange box is. You can also use the chat function if you want to send a message to us. The session also includes the question and answer. And so please use the question and answer if you have any questions. The webinar will be recorded and will be emailed to you. So if you lost because we were going to practice PIM DEA software, and if you lost for a reason because there are too many things, you can re-practice it with the software later. And a survey will be emailed to you later by OR Society to get some feedbacks. So keep an eye on your emails as well. DEA, as we know, that is a data envelopment analysis, a method to compare the homogenized operating units, initially implemented in 1978 by Charles Cooper Rhodes, is a way that to compare decision-making units, for example, the schools, banks, hospitals, universities, and any other decision-making units that you can think of. So each of these decision-making units using some inputs, these are resources available to decision-making units, and produce some outputs. For example, in banking, inputs are the money available to the bank, for example, the saving account, etc. And the outputs are the service that the bank provided. For example, the loans or the number of accounts they're serving or the number of transactions, etc. And similarly for other variables. So DEA make it possible to compare these operating units against each other. And for that reason, we call it the comparative analysis. Very simple case, I explain it to you graphically for those who doesn't know much about DEA. Consider the case that we have few hospitals and we want to measure the efficiency of nurses that they serve the outpatient and inpatients. In these cases, we have 70, for example, for hospital 1, we have 72 nurses that they serve 1,200 outpatients and 360 inpatient, and so on for other hospitals. If we graph them in this two-dimension graph, as you will see, hospital 2 and hospital 3 are the hospital that they serve most number of outpatient and inpatients, and so they become efficient. And then we can define the frontier or the efficiency part of the decision of the production possibility set. And each unit, for example, unit 1, hospital 1, can be compared against the frontier in order to get the measure of the efficiency. And similarly, this, in the case of you have more than 2 input and output, can be formed in a linear programming format. In a similar way, if you have a case of the 2 inputs, for example, in these cases, we want to measure the efficiency of the hospitals in terms of the number of doctors and nurses they serve outpatients. We can do a graphical presentation of the DEA in this form. And each unit again is measured, efficiency of each unit is measured against the frontier. In this case, hospital 1 is inefficient, hospital 2 and 3 are efficient hospital. So again, this can be also formulated in a linear programming. For that reason, as you will see, DEA is very simple linear programming. Although it's expanded now, there are many, many other models, but two simple models that initially been introduced, input and output oriented DEA, that produce many, many applications. So as you can see on the survey of the DEA papers, now these days there are nearly 1,500 papers each year published on DEA methodology and application. So there are huge demand, huge expansion of the DEA. Now we develop a software called Performance Improvement Management, which is available on the website of deasoftware.co.uk. And so the aim of this session is to introduce you to some of the features of this software. As you can see on this screen, this software is got different parts, including the data explanations, the modeling, and the result, which can be either presented in the tables or graphs. So both graphical presentation is also available. Now, the best is for me if I show you some of the features of the software in on live presentation. So what I will do, I will start the software. So this is the PIM DEA software, as you will start it. And once you start the software, you can see everything is blank. You can start a new project. And once you start a new project, you can either create the data directly within PIM, you can type the data in, or you can import it from Excel. So very briefly, I show you how you can create the data directly in. So when you create data directly in PIM, assuming you have case of number 5 units, 3 input output together, and 2 periods of the data. So I put number of categorical variables 0 at the moment, but later I explain what is this about. So once you click on the finish, the software will create for you a template of the data, as you will see here. And this template of data includes the DMUs. So there are 5 DMUs. There are 3 variables. You can rename them to input 1, output 1. You can also add description if you want, but I'll leave it blank at the moment. So output 2, and the data can be typed directly in software. So you can type the data like a spreadsheet here. You can type the data directly here. Alternatively, if you have your data saved in an Excel file or somewhere else in a Word file, for example, you can also copy and paste that data to PIM. Let me show you, for example, here. I've got in this Excel file, this data set. I can use Control-C, and when I go to PIM, using Control-V, you can paste this data to PIM. And similarly, if I use this data, Control-C again for period 2, can click on the period 2 and use Control-V to paste the data. So you can create your data set directly within PIM, either by copy and paste it or just by type directly to PIM. And once you have your data set here, we can see, for example, some statistics here, summary statistics of the input and output. What's the average standard deviation, variance, minimum, maximum, etc. of each of the input and output. You can also see the PPS of the software, of the examples that we have at the moment. So the PPS can be drawn on a case of 1 input, 1 output, 2 input, 1 output, and 2 output, 1 input. Because we have only 2 dimensions graph here, we can use up to 3 variables. If I use, for example, 1 input output, say input 1 against output 1, so the PPS in period 1, as you will see, is shows in this case. Now, this, for example, unit is DMU4. If you want to show the units which units are efficient. You can click on the efficient unit. That will show you which units are efficient. So unit 4, unit 5 are efficient. And if I click on period 2, for example, you will see that DMUs on unit 2 are also shows here on period 2. So DMU 4 and 5 in period 2 are efficient units. So this is the way that you can demonstrate the PPS graphically. If, for example, we take one unit here, DMU1, you can click on DMU1, and that will show you how DMU1, let me just use only one period. So that will show that DMU1 can be projected to this input-oriented projection and output projection, how it can be projected to the front end. So this was the way that you can create data directly within PIM. However, in most cases, let me close this save. I can also save this, because if you save this, you can get back later if you want. So I call it sample 1. So I'm going to close this PIM because it's already saved. I'm going to close this Excel as well. Now, what I've done, because in most cases, what we have, the data is already prepared in PIM. On this example, I've got a data set which is being collected from sewerage service in England and Wales. There are 5 variables in data set, including expenses, for example, and other variables, including populations, length, area, and capacity. I'm not going to explain what are the input and output. I'll put a source of a paper that you can refer to that in order to discuss which variable is input or which variable is output. There are 61 districts which belongs to several companies. Now, on this Excel file, what I've done, I created one sheet, include all the DMUs. The DMUs are named A1, A2, A3, A4, A5, A6, etc. for the company A in district 1, 2, 3, 4, 5, 6, and so on. And the data set are saved in 5 different periods. Say, for example, data in 2015, 16, 17, 18, and 19. So I just call it period 1 to period 5. So in each period, as you will see, we have variables and we have DMUs and the values. So that's simple. If you use this template, which I'm going to close this, you will be able to create your data for the Excel file in order to read it. Now, what I'll do, I will start the PIM.
I can learn to understand you much better if I can get familiar with the way you...
Sorry. Let me start PIM here. I've got 2 screens, so I need to follow a second screen.
I can learn to understand you much better if I can get familiar.
Okay, so let's start PIM with this data set. So what basically I do, it says PIM, and I'm starting a new project on the PIM. But in these cases, when I said new project, just keep going to the second screen of mine. So I need to bring it back to this screen. Sorry. The problem is this 2 screen is confusing at the moment. Okay, I think I managed to bring it to this screen. Yes. So basically what I've done, I imported data to PIM. And once you import it, we'll see that we have data in these cases, a data sheet in period 1, period 2, period 3, period 4, and period 5. So these are 5 periods of the data we have. The DMUs are shown here, the input and output variables. In these cases, we have a categorical variable. We can also show them, but there are 5 periods and summary statistic as well as the PPS. As you will see, the PPS can also be explained in a format that way. If I choose, for example, input variable, which is the expenses against any of the output variables, say, for example, capacity in this case. And when you have a 2 input or 2 output cases, so let's use cases of that 2 output and 1 variable, which is the input variable. And I'm choosing capacity, for example, and two variables as output. So these 3 units, as you will see, are efficient units. Now, in order to show the efficient unit, you can click on the efficient unit, and it will show the name of the efficient unit, which is A2, E1, and H2. And this unit, for example, A1, which is inefficient, and if you want to see how this unit is projected, we will see that how the projection is done. So in order to A1 to be efficient, the 2 variables need to be moved to this point on the front here. I think I can stop at this here. If there are any questions, Emmanuel, is there any question on this part?
Yes, there are a number of questions. There is one about whether it's freely downloadable.
Yeah, there is an evaluations version of this software, which is freely available, and I will send you the link at the end of this webinar.
Okay, then there is one about, can we have a link to download? Okay, that you've answered that. Does the software work well with big data? If so, how many samples do you expect?
It will depend the number you say, but if you mean the big data, you mean the number of DMUs. Yes, the software has no limitation of the number of DMUs. It can handle any number of DMUs. Yeah. And of course, the input and output as well. There is no limit.
I think there's another one that says, looking forward to knowing how can categorical variables be analyzed through PIM, as most data are numeric. I think you'll find it is always numerical data, but the data fall into different categories. So that's what we mean by categorical data. So not quite non-numerical. They are numerical, but in different categories. I think maybe Ali will say more about that later. There is another one from India. I want to know that how to estimate the technical efficiency by incorporating bad output.
So let's we continue with the rest of the presentation, because some of these questions may be answered later. Now, once you have your data in, as you will see on the left side of the software, there is trees for the data and there's a tree-wall model. So you can add a model here, which I call it, for example, model 1 or model whatever the number is. And once you define the model, again, it goes to my second, maybe I stop the second screen because it's, okay, once you have a model, so it says model 1. So I need to, okay, so once we have model 1, what basically you need, first thing we need to choose is the variables. So I'm going to choose input variable, which is the cost or expenses in these cases. And for simplicity, I'm choosing 2 variables, say, for example, area and the capacities here. So these are the 2 variables that I selected for demonstration purpose. If we don't do anything and simply run the software, it will run a simple CRS model. Input oriented. So model 1, as you will see, the summary which says input oriented CRS model. Some of the features are disabled. The input variable and output variable are shown here. and it's run on 5 different periods. Say, for example, 5 different years of the data. If you click on the efficiencies, we will see the efficiency score of each of these DMUs, and of course within each period. So period 1, period 2, period 3, say 3 or 4, etc. So the efficiencies are shown here. Although we showed with 2 decimal places, but you can show them up to 8 decimal places if you want. Apart from the efficiencies, there are other features within software. Say, for example, you can show the efficiency trend. As you will see here, we have 5 different periods, so you can see the trend. If you have more than this number of periods, then you will see the trend easily. So for each of the periods, we can see how the efficiencies change from one period to another period. These graphs are exportable. If you want, you can screenshot it, or you can export it to Word, or save it as PDF or other format if you want. The efficiency plot also can be shown here. Say, for example, this shows how the DMU efficiency are compared with the others. Say, for example, this is DMU 1 at the moment, but if you want to single out, say, DMU C10, you see that this is the efficiency of the DMU C10 as I said. So some plots you can show them, but in order of the DEA, what do we need? We need to look at the lambdas, the pairs, the targets. So these are easily can be shown here. So this is the lambdas. If you run the linear programming, we need to also look at the lambdas on the linear programming. So these are the lambdas. If you wanted to with more decimal places, you can easily find them. And apparently the lambdas refer to the positive lambda refer to the pairs. So you can easily see which unit become pairs to other units. So in these cases, for example, we have 3 different, 3 efficient units, A2, H8, and J3. And we'll see that A2 appears 52 times to be pairs to other units, and J3 appears 46 times. Say, for example, for unit A6, A2 and J3 are the pairs. But for unit C5, for example, H8 and J3 are the pairs. Apart from the pairs, we can also look at the targets. So if the unit is inefficient unit, it will tell us how the unit become efficient, what percentage of the input need to be reduced. So that is what we get the target for each variables in the data set. And also it depends whether you run the input oriented and output oriented. The slacks are also shown here. So obviously the positive slacks refer to the if the unit is efficient and there is a positive slacks, that refer that unit may be a weak efficient unit. So these are the things that we need to check. The weights are shown here. This is for the case that we run the weight model. And so we will see the weight of each of the variables. So various information you can simply get out of this model by one click. Now, if I want to run, this model was CRS model. And if I want to run a VRS model with the same condition, with the same characteristic of this model, the easiest way is if I copy this model. So I'm going to copy model 1 here to model 1. I call it VRS. Because I have another model 1 here, maybe if you want, you can also rename this. All the models can be renamed. So if I rename this model, sorry, if I rename this model to model 1 CRS, in order just make sure that you know that which model is referred to what. So this is the CRS model, this is the VRS. Now on the CRS model, when you look at the general, we see that the constant return to scale is selected. The VRS model, we did not run it yet. It's exactly the same as CRS in terms of the characteristic of the model. But what do we want? We want to change it to VRS. So on the general tab, I'm going to change the CRS to VRS. And by running this, only the model 2. Now what we see here, the efficiency of model 2 on the VRS And remember that this was the efficiency on the CRS. So there are two different model, one CRS and one VRS. We run it. Now, again, when you select in the feature of the model, in the software we have option for constant return to scale, variable return to scale, non-increasing and non-decreasing return to scale, scale efficiency, and most productive scale size. All of this you can run it on input-oriented or output-oriented, and also you can run it on non-oriented model. I think at this stage I will stop if there is any question, and then we'll continue after. Emmanuel, are you there? Hello.
Hi, Ali. I'll pick up the questions for you. We have one from Katsushi. Does this software work well with big data? If so, how many samples do you experience?
I think I answered
lagging
that.
Computing the efficiency of scale. Sorry, has that been answered?
Yes, that's been answered. The software has no limit, so you can enter any number of DMUs and input and output on that.
Okay, sorry about that. Another one, how to estimate the technical efficiency by incorporating bad output?
That is the issue of undesirable output. So the way that we handle it within the software to transfer the input variable to the way that we can handle it at undesirable. Now there are cases as if the undesirable output you have in your model, you can transfer it to as input, considered as input variable, but also you can create an inverted variable. So on the input output variable, if you click on the add new, say for example, I've got an example later, but say for example, if this variable is undesirable, you can click add new variable and do the calculations. As the calculations, I can use 1 divided by, say for example, this variable. So that in this case, the variable will be inverted. So we have a data transformation within the software. Within the software, you can transfer the data, transfer a bad output to either input side or 1 divided by bad output, which can be considered as a good output. That's one way to deal with undesirable.
Okay, thank you. How can we set the model to either variable RTS or constant RTS?
That is I already explained here. So you can see variable return to a scale, and this is constant return to a scale and variable return to a scale, two different models that we already set it up here. As I explained, you can also say, for example, copy this model, create a new copy of this model. So I call it model 1, but call it increasing return to a scale. So this is a new model. Let me click on this new model. Click on the general, you can change it to increasing or non-decreasing. So say increasing return to a scale, which refer to non-decreasing return to a scale. I can consider this one and run this as a non-decreasing. So basically you can create any copy of the model and change the parameters within the software.
Okay, thank you. A question from Joshua. Are there any tools in the software to help decide on VRS versus CRS, or do you have to decide outside of the software using domain knowledge?
Yes, the options that currently available within the software is called MPSS. So if I select variable return to scale and MPSS here, let me run this model with the MPSS.
Can I add on that while Ali is getting that ready? The question of whether you use CRS or VRS is something you would need to decide from the context of the industry or situation you're modeling. In other words, if you believe that when the inputs go up by a certain factor, the outputs would also rise by that same factor if a unit is efficient in that industry, then CRS would apply. But if you cannot sustain that argument, then you need to use VRS. And of course, there are variants between CRS and VRS. So that's just to add to that while Ali is getting
yes,
ready.
that's correct. But in respect of the which DMU is operating on the CRS and VRS, if you run this MPSS model, it will tell us, for example, this variable, this DMU A1, for example, is on the DRS, A2 is on the CRS. And so, for example, let me see if any of on the, yes, this is CRS, DRS again. So you will see that which part of the frontier it can be projected. Once you have the model, I think we should continue with the rest of the presentation, and there will be time for question and answer. So once you have the model, you finish your model, you can save this. And once you, and if you closed it, when you next time open your PIM, the PIM that you saved already, and you will see that all the models that you already set, they are there. So they're not going to be disappear. So the models that we already designed are here. So you don't need to run those models. If you want to run a new model, you can add it to the software. So this is good things because basically when you have a project, like a PhD project or an industrial project or whatever, you start with the data set, you design the model and change the options of the model, and you keep everything in one platform on the software. Because there was a question about the categorical variable, what I will do, I will show you another example here. I've got the example on the banking data. These are real data set collected from several banks. The name of the banks are removed here, but these are the banks in Gulf states, and some of the variables we have here. So we have variables that, so first of all, we have 20 DMUs refer to several countries, country 1, country 2, country 3, etc. Some of them are small banks, some of them medium, some of the larger bank. Some of them do international transactions, some they don't do international transactions. So these are the variables that we call it categorical variable. So basically, they divide the data, the DMUs, to different categories of it. And we have a data for 3 different periods. Now I save this data in Excel, and when you start PIM, basically you start with a totally new blank PIM project. What do we need? We need to import that data, which I will show you how to import the Excel file, and create a project. So I'm going to say new project and import data from Excel. So this time import from Excel, browse the data. So this data is banking data. Be careful when you're importing this data. If your Excel is open, that would be an issue. So you make sure that your Excel is closed. So I'm going to say next. And in this way, we have one main sheet which define the variables, define the DMUs and which and the categories as well. And we have 3 periods of the data. So there are 3 periods of data. So once you import the data, again, the PIM will create for you 2 trees. One tree is about the data, which you see this at the actual data, and the categories are shown here. So the location, size, and international transaction, whether they do or not. So they shows here. And the variables you see, the categorical variable, as you will see here, the periods, we have 3 periods of the data. The statistics also given for each periods. And the PPS, of course, you can draw it for each of the PPS, for each of the periods. Say, for example, staff costs against the loans, for example. So this is PPS in 2007, and this is PPS in 2008. So we can easily compare these 2 against each other. When we start a new model, so I call it model 1 again. And for the purpose of demonstration, I'm not discussing about which variable is how to choose the input-output variable, but let's say a staff cost and other costs as input, loan and new account as output, as example that to demonstrate the software. By running this, as I said before, it will assume that the model is constant return to a scale, input oriented, etc. If you want to change the output oriented, you can do the changes here. What I wanted to show you, the categorical variable. So first of all, efficiency that you see as shown are here for all the DMUs. The categorical variable that we have, if you click on this category here, and if you says add new selections, and I says I want to run this only for categories or the banks in country 1. So at the moment, I'll put the conditions here. Basically, location is country 1. If you evaluate it, you see these are the number of banks in country 1. I can also rename this to country 1. So make sure that this is what I'm presenting. I will also create another selections, but I'll do it country 2 only. So basically, in these cases, you see these are the country 2. These are the conditions. I can rename this to also country 2. And I will do another one is country 3. Sorry, country 3. Now you can see these are the number of units in country 3. I rename this to country 3. So basically, when we run the software, it will run it, each model within the country separately. But if you wanted to run it for all country at the same time, what we can do, we can also select all 3 countries. So there will be one new model, which I call it all countries. And that you can see. And if you know how to type the SQL, you can type your conditions here. So the condition at the moment says location country 1 or country 2 or country 3, but you can mix and match. Say, for example, I want to say any banks which is in country 1 or country 2 and either medium or large, and they do international transactions. So let's see how many banks we have. There are none in these cases. So basically, what I will do, I will remove some of this to make sure that. So basically, what about locations in country 1 or country 2? So we'll see the country 1 or country 2. But you can also mix and match the conditions with other variables that you have. So various and or you can use if you want it. Now let me run this model. As you can see, there is different selection has been run. When we get the efficiency, we get the efficiency in 2007 in country 1, in country 2, in country 3, all countries together, all country 1 and 2 as we selected together. And that we get it for 2008, 2009, etc. separately. So basically, you can find the efficiency within each country. We might run out of time, so I need to show you a few other features. And I'm going to add one cases to explain what are the other options of the software. Model 2, I'm going to add here. In this case, again, I'm using the 2 inputs, staff costs and other costs against the loan and new account. What I want to show you how to run the Malmquist index, because now we have a data over 3 periods. You can easily use Malmquist index. There are different models is implemented. One model is called FGNZ, which is a standard constant return to Malmquist index. And if I run this, now you will see the efficiency are provided. But in this case, we also get table of Malmquist index, which shows technical change, efficiency change, efficiency each period, so period 1 and period 2, which refer to 2007, 2008 in this case, and 2008, 2009 if you want. but also we got the component of the Malmquist index. For those who aren't familiar with the component of Malmquist index, all the components are also reported here. And of course, if I change this to VRS model, I can run the Ray and Desley VRS decompositions. Now, at the moment, this is not possible. This is disabled because the model is CRS. If I disable this, go to the general, change it to variable return to scale. Now, when I go back to Malmquist index, I can use Ray and Desley decomposition, which is called variable return to scale. And when you run the model now, what do we see? The efficiency are reported on the variable return to scale, but also the Malmquist index also reported. Of course, scale efficiency change is reported. It could be the case that there are non-infeasible score that has also been explained here. So we will see the efficiencies on the variable return to scale, but we will see the Malmquist index. Some other feature of the software, as we may run out of time, is about, say, for example, super efficiency. But before that, just one more thing I want to explain about the Malmquist index. So if I set another model, I call it model 3. The good with this software is you can design any model if you want, and then change the parameters, change the input and output variable or characteristic of the model and run it again. On the Malmquist index, we also have an option for circular Malmquist index. This will design for you a global frontier. And if you run this, we see that efficiency reported on the Malmquist index on the global frontier. So we have a circular Malmquist index, efficiency change, and a frontier shift as we have in the software. And also this is for 2007-8 as well as 2008 and 9. So Malmquist index can easily be handled within the software. There are some other features, but I stop here for a couple of minutes if there is any questions. Emmanuel?
Yes, I'll choose some of there are several questions. Let me start. One is going back again on how to choose VRS, whether that's preferable to CRS. And I think we've answered that. We said it depends on the context. There is a question about the software and big data.
That's why we already answered that.
Yeah, I think all we can say is you can have an unlimited number of units. Somebody's asking if they can get a recording of the session.
Yes, the session is recorded, and then it will be sent to them on Friday.
Okay. Somebody's asking about, did you mention the non-oriented models?
Yes, we have a non-oriented model. As you will see on the general options, there is a non-oriented case here. And this is the case that when you basically project your DMU, you project it with 45 degrees. So with the same scale as reducing input, same scale reducing output. Sometimes it's called hyperbolic model, yes.
Yeah, in other words, you can change both inputs and outputs at the same time. Also, there is a question about how to choose, when purchasing it, how to choose the number of DMUs. Somebody is asking if I have 50 or 100.
That's all dependent the model, your application. So if you really want to run the model with 50 banks, so you need to choose 50 DMUs. But if you have a model, if you want to run the software on the case after like 200 DMUs, then obviously you need to choose at least 200 DMUs. But in terms of the input and output and the number of periods, there is no limit.
Then there is a question about classes on DEA, whether we have any online classes.
We don't have right now, but we were thinking to run one online courses very soon, perhaps in January and February. We will announce that.
Okay. Then there is a question from Emmanuel Kwasi asking, is it's okay for the PIM software for the basic models, but what about the more advanced model.
That's what I want to explain it now. So let's give me 5 minutes, Manuel, for some other features of the software.
Okay.
Unfortunately, the time is very short. We are not able to show all the features, but our society agreed to run another webinar on the advanced features of the DEA as well as the software. So, but for now, if I click on model 1, for example, and once you see the models, the characteristic of the model here, now we have options for the DMUs, and in this way you can exclude some of the DMUs if you want. So if you want to remove some of these DMUs from your model, you can also exclude them. There is the option for categorical, which I already explained it, but mix and match category is possible. One of the features of the software is non-discretionary input. So you can, if you want to set one of the variable to be non-discretionary, for example, a staff cost cannot be reduced. From policymaker, for example, it's not possible to reduce the salary of a staff, or it's not possible to expel out any staff. So in that case, you can put it as non-discretionary input. So non-discretionary and also non-discretionary output is also possible, but that's of course depends whether the model is input oriented and output oriented. If it's input oriented, then it's only non-discretionary input is available. If the output oriented model, then the non-discretionary output variable is open to you. And of course, if it's a non-oriented, you can fix any of the input and output at the same time. So I'm going to put as input at the moment. So if it's input, then you can say which variable is non-discretionary. But even more advanced features called IO priorities, rather than to fix one variable to be 100% or non-discretionary as 0%, say if I says this variable as 0, that means this variable cannot be reduced anymore. And also it's the input variable, that means it's non-discretionary input. But you can also put some features. Say, for example, this variable can be reduced up to 20%. So it's possible to put some priorities to each of the input and output variable on this code. This is called IO priorities. Again, this is one of the advanced features that you need to be using by very carefully. But there are papers published on this area. The periods I already explained. However, you can also expel out some of the periods if you don't want, for example, to consider 2007, you can move it back to the other, to this site. The Malm quiz index available on all CRS, VRS, as well as circular Malm quiz index. But one more options that probably you will be using is called super efficiency. There are two models available. One is called simple super efficiency, one called super efficiency with threshold, which we can use it for the case of outlier detections. I'm going to run the simple super efficiency here on model 1. So when you have the efficiencies, now we will see that some units are beyond the 100% because they are, we put it as a super efficiency. So these units, which are above 100%, basically these are the efficient units, but now we use them, we put the super efficiency, we now also discriminate between this unit, that which of this unit is better generally as compared with the others. Let's go back to other features. Now, another features that we have is called weight restrictions. This is one of the very popular use in DEAs that you can also impose any weight restrictions. Say, for example, we can say weight restriction on a staff cost should be higher than weight restriction of the other cost. So in this case, we can put this weight restrictions in the with these conditions here, and you can also change it that is a weight in a staff cost is higher or lower than the other variable by putting this variable. And not only 1 and 2, maybe we can say it should be more than twice of the weight restriction weight of assigned to the other cost, and so on. So all the weight restrictions, all the weights you can assign here at any number of weights you want to add. We got allocative efficiencies. This is about cost efficiencies and let me put this super efficiency back because allocative efficiency does not work on the super efficiencies. I disabled the super efficiency in order to make to run the allocative efficiency. This is about cost efficiency, revenue efficiency, and profit efficiencies. So if you have any cost involved with each of variable, you can type your cost. Say, for example, the cost of this is 100, or the cost of this one is 150. As an example, you can type this for any any DMUs or for all DMUs at the same time, if you want it. If we have another sessions on advanced modeling of the PIM DEA software, we can show this in more details. And one more option, which some of you also ask, is about bootstrapping. Bootstrapping is available within the software. So it's possible to run 2 different bootstrapping based on the 2 different bandwidth of the software. I'm afraid we have run out of time. There are many other features which you can apply, but if you get the evaluations copy, you will see, you can practice it on your own time. Is there any questions?
There's some questions. Somebody says, I have version 3.2 of PIM DEA. If a new version is released, I will be able to use it with my previous license?
This all depends whether you have a maintenance signed by PIM or not. If you have a maintenance, you get a free upgrade, of course. If you don't have a maintenance, then you need to contact the PIM in order to see what sort of costs would be involved.
There's one question from Lemuel, but it seems to be rather specific to a situation, so maybe we can take that offline. Let's see. Can you use different departments of a hospital as different DMUs and then choose one variable? Is that correct way to proceed?
Sorry, I don't understand. Different department, yes, you can use different department, different DMUs. That's possible. But
well, I mean, what I would add is the units have to be comparable, because the foundation of DEA is that you're comparing homogeneous units, as Ali said at the start. So if you're talking about the hospital, depending on what aspects of the departments you are comparing, it may not be possible to compare, let's say, the heart specialist unit with a perinatal care unit, for example. But you can compare different departments in different hospitals, all the heart departments across hospitals, or all perinatal care units, or something like that. The units have to be homogeneous. Can I do regression for the factors affecting technical efficiency or total factor productivity for panel data?
You cannot do regression within the software, but all the results of the software can be exported to Excel. So for example, once you have efficiencies or you have targets, all results, you can export it to the Excel and do any regression in Excel if you want. Okay.
Okay, you mentioned the advanced models. Can estimate its just profit efficiency by using this software?
That's what I explained. That's referred to allocative efficiency. So it's cost efficiency, profit efficiency is possible to do it. Some of the features at the moment I put on the screen, you can see. I was not able to demonstrate them, but these features are available within the software.
So the models present better. So it's also very important. Okay. Someone is saying about the classical Malmquist index and compared to the Ray and Desley. So is the model of Schubash-Ray, the Ray and Desley, important to carry out DEA?
That model is referred to the variable return to a scale. So basically, if you decide to do constant return to a scale, you need to use the classical Malmquist index. If you decided to do variable return to a scale DEA, you need to choose the Ray and Desley decomposition.
Mm-hmm. Okay, I think we're probably at the end. There are quite a few thank yous from people. So I'm sure all of us are very grateful to you, Ali, making this demonstration. So if there are any comments you want to say as you close.
No, thank you very much. Thank you to you, Emmanuel, to chair these sessions. Thank you to everyone to participate in these sessions. I'm sorry that the session was too short to demonstrate all features of the software, and there was a disruption because I had two different screens. So I disconnected one of the screen in the middle of the webinar. This webinar is recorded, will be emailed to you, so you can practice it if you want on your own. I will also make the two data sets that work within the webinar available to you. And a free copy of the software is available on that link that I show you, https bit.ly/ors-DE webinar. If you have any more questions, you can directly contact the software or any of us. And thanks to our society for organizing this session as well.